Hello tubes, this is Flat Louie and we are disproving gravity using E equals mc squared. Now what we're going to do is look at three separate equations that help us understand that gravity is just energy, and then we will be looking at some test footage recently declassified from 1955. Now first off, what is special relativity? It's energy that comes from mass times the speed of light twice. Now the speed of light is c. That means constant because the speed of light never changes. It's 300,000 kilometers a second. It's been that, it's going to stay that. Now in this expression, the only variable that can change is mass, m. So what if we add energy on the other side of that equal sign when we can't raise c? We have to add mass. We have to raise the mass. The mass goes up, the gravity goes up, and it's as simple as that. I mean, this is the type of stuff we learned in school. 2 plus 2 cannot equal 5. We all know this. 2 plus 2 is 4. If we have 5, one of the integers has to go up, and that is the mass. You know, science actually admits that this principle is true. Their mathematics predict black holes, and they can't deny that. Academia calls this mass defect. When energy is taken out of a system, the mass decreases. In 1905, Einstein himself wrote the formula for mass defect as a companion equation to E equals mc squared. We see the same example in quantum mechanics. This was Hawking radiation, black hole thermodynamics, which stated that even the most extreme examples of gravity, black hole singularities, eventually evaporate. And there you have it, gravity changing just from the amount of energy you put in or take out of a system. Now let's recap these three. Special relativity, mass is interchangeable with energy. Mass defect, mass does rise and fall if you add or remove energy. In Hawking radiation, gravity burns out by expenditure of energy. Now that's wild to think about. Gravity is just a symptom of electricity or electromagnetism or radiation. Now, can we see examples of these in nature? Indeed we can. In fact, some examples we see every day. But what about those examples of high energy interaction? Nuclear explosions, EMP discharges. What we're going to see in this video are steel cables made extremely heavy by being doped with radiation. The cables are denoted in red here, as you can see, and let's watch them as they propagate forward along with the blast wave. You can see the cavity forming there on the left, a cavity beneath the surface. Now as we move forward a little bit, by this point the cables are gone. What we see impacting here is just the gravity echo. And impact. Once again, let's see the one on the right. And impact of another possible singularity. Let's see that once again. Now we can see the same anomaly in a different blast, but in the air. Here's a cavity. A temporary void that is stronger than the nuclear blast that's enveloping it. Now we've gone over the equations and seen some video of mass defect in action. What other examples are there out there? High energy, low energy examples, natural and man-made. If we stop to look, we find this everywhere. The suction of tornadoes, the circulation of hurricanes, demolition concerns, armor-piercing munitions, volume differential, aircraft coefficients. it's everywhere. Let me know what examples you've found down below. Do you have a favorite controversial topic that you'd like to see addressed or even vindicated? Tired of not knowing the answers? Well, that's what I'm here for. Come meet us on social media and get involved. If you're dedicated to this cause and you like the caliber of my videos, come donate at Patreon and you can take an active hand in the material I release and get a shout out. Remember to comment, subscribe, like, share, and most important, tell a friend. Open eyes, open minds.